Welcome back to Mihinsara Tech. Today we're diving into one of the most important, shortest path algorithms in computer science, the Bellman Ford algorithm.
It's like Dijkstra's older cousin, but with a superpower. It can handle negative weights. So let's see how it works, when to use it, and why it's relevant today. What is the Bellman Ford algorithm? In simple terms, it's an algorithm that finds the shortest path from a single starting vertex to all the other vertices in a weighted graph. It works with both directed and undirected graphs, and unlike Dijkstra's algorithm, it can handle edges with negative weight as long as there are no negative weight cycles. Here's the big idea. The Bellman Ford repeatedly relaxes all the edges in the graph, meaning it keeps checking if the shortest distance to a vertex can be improved by going through another vertex. It does this exactly v minus 1 time, where v is the number of vertices. Why v minus 1? Because in the worst case, the shortest path can have at most v minus 1 edges. Here's step by step. Initialize distance, relax edges v minus 1 times, check for negative weight cycles. Let's run through a quick example. Look at this example that is shown. Step 1. Set distance a equals 0, others equals infinity. Step 2. Relax edges 3 times. After each round, distance gets better. By the end, you'll have the shortest distance from A to every node. This slide shows the update after each iteration. Now, why use Bellman Ford? It works with negative weights, simple to understand and implement, but slower than Dijkstra's algorithm. Doesn't work if there's a negative cycle because you can keep looping forever. And that's the Bellman Ford algorithm, a reliable way to find shortest path even when the road gets a little negative.